Thank you. Hello, everyone, and thank you for joining us for another session in our 2021 Climate Action webinar series. My name is Frank Bostrom, the incognito AIA co-chair of AIA California Committee on the Environment Education Subcommittee, and I'll be the moderator for today's segment. As you know, AIA California has developed an in-depth series focused on understanding and implementing the AIA framework for design excellence. This series will run through the end of the year and will feature monthly hour-long general climate action webinars, as well as 90-minute webinars that dive deeper into technical topics. Additionally, AIA California has partnered with various organizations to bring bonus content to you in the comfort of your office or wherever that may find you. As always, all webinar content and additional resources will be available on the AIA California website shortly after each presentation. Housekeeping. Please use the Q&A function to ask questions for today's presenters. You can also like a question and move it up on the top by just pressing the appropriate button down there. And if you like the question, it'll rise to the top. And that's what we'd like to see. In addition to NRMCA and CNCA and CalCIMA, we'll get to all that, what it means in a minute, and build with strength, continual support of the AIA climate action initiatives. They will be presenting our partners at the 2021 Monterey Design Conference. MDC is coming to you this year, wherever you are. It's going to be coming in a virtual format, and it's our way of inviting you to see what makes the Monterey Design Conference, the Architects Retreat. And that's why we have so many loyal attendees. Our headliner speakers this year will join us from Portugal, Japan, England, Boston, and of course, California. So clear your calendars for October 21 and 22. And carve out time to focus on these amazing architects and how their work is shaping the world. I've been a long time attendee to it, and I can speak very highly of it. It is well worth your time. It is well worth attending. And with that being said, now on to today's webinar. Today's session qualifies for one AIA HSW learning unit for those who are watching live. And AIA California staff will report these units for you. The session is also being recorded and will be posted on the AIA California website with additional resources and a PDF of the presentation shortly after today's session. Today's session is going to focus on Portland Limestone Cement. As the foundation of modern society, concrete is the most widely used construction material on Earth. Even small changes to its formulation can dramatically affect the construction industry's carbon footprint over time. By preferring the use of Portland Limestone Cement, PLC, in specifications as a one-to-one replacement for Portland cement, architects and engineers will enable meaningful reductions in CO2 emissions. Key word here is Portland Limestone Cement and Portland cement and the difference, okay? I would like to quickly introduce today's partners before getting on to the program. Tom Tietz is Executive Director of the California Nevada Cement Association. That was one of the acronyms. Tom's career started in architecture after receiving a Bachelor of Science and Master of Arts degrees in architecture from the University of Illinois and practicing as a licensed architect. Tom has been working for trade associations since the mid-90s. These associations include CNCA and the Concrete Reinforcing Steel Institute, and he has provided seminar topics to agencies, architects, engineers, contractors, and universities across the U.S. Nathan Forrest, in the role of Technical Director, Nathan provides resources, recommendations, education, and technical expertise to public agencies, design engineers, project owners, developers, and contractors. Prior to his work with CNCA, Nathan worked as a consulting materials engineer on numerous large Caltrans projects in Southern California. He has a bachelor's degree in civil engineering from the University of Arizona and is a licensed civil engineer in the state of California. He maintains certification from ISI, ACI, and NRMCA. Nathan also serves on prominent committees within Caltrans and the Green Book for Southern California. And Caltrans and Green Book are very well known. Tim Blake is an associate AIA, is a consultant to the California Nevada Cement Association, CNCA, is communicating with the architectural and development community. Tim is aiding in campaigning of information and informing architects, engineers, and construction firms for the first understanding and ultimately implementing of a more environmental friendly cement to the marketplace. Tim feels it is vital to play an active role in improving the global climate situation that is on almost everyone's mind and will be for future generations. With that having all been said, we have successfully completed the introductions and we can begin.
All right, thank you. I will get our presentation up and going here. Somebody can give me a high sign that it's looking right on their screen. All right.
Looks good.
Great.
All right, Tom, it's all yours. Take it away.
Thank you, Nate. And thank you, Frank. I wanted to thank Frank as we get started here. We had a conversation with him back in January, which really set forth the 4 webinars that have happened this year with AIA. The National Ready Mix Concrete Association put on 3 webinars earlier this year, all regarding sustainability in concrete. I'm very impressed with how well those were attended. And one thing Frank told us right from the start is not to take it easy on the architects here. We wanted to make sure we got into depth in what we were talking about. That was clear that happened in the previous webinars. And you'll notice today too, we're at moments we will get pretty deep. And part of that is inspired by another comment he made, in that so many architects are trying to make a difference and do the right thing, but sometimes get stuck. And that might be with your structural engineer. It might just be difficult to know what to do. We don't want you to have any questions about how to make Portland Limestone Cement a reality in your projects after this presentation. And you'll notice that Nate Forrest, our technical director, will be a tremendous resource to you, particularly in coordinating with engineers or contractors. And then we also mentioned Tim Blake early on. He's on board with us in order to make connections for you. If you have a project or working on it with a developer and trying to connect with a supplier, he's active in the market right now to try to facilitate those connections. And I just want to mention that all these services are absolutely free. We don't charge anything for that. We're a not-for-profit trade association here at the California Nevada Cement Association. So if you go to the next slide, Nate, I pretty much just explained who we are, but we're primarily known to be a technical resource for you, much as is the National Ready Mix Concrete Association, who's helped provide these webinars this year for the AIA California. Our learning objectives today were pretty well covered by Frank to start with. So we're going to go right into learning objective number 1. And this is where we'll get Nate get started on how to gain insights into how cement is made and how CO2 emissions are created in production.
Thank you very much, Tom. What we have here is kind of a cartoon version of the production of cement, moving from left to right across the screen. We begin by excavating limestone, naturally occurring deposits in the earth, grinding that material up into a fine material, heating it up inside of a kiln to drive a chemical reaction that we'll look closer at, and then blending it with a few other ingredients at the end, and ultimately delivering it to customers for use, often in ready-mix concrete, but also in other applications, direct applications for cement. This thermal process I want to focus on just for a moment, where we heat the limestone up to a relatively high temperature, 1430 degrees Celsius or 2650 degrees Fahrenheit. This takes place inside what we call a kiln, which is a steel tube about 8 feet in diameter and 150 or 200 feet long. And this is where a couple of important things happen. You can see on the right side here, we've got a burner that's often fueled by petroleum products, natural gas, coal, petroleum coke, although increasingly agricultural waste and industrial waste products are going into that process to help us reduce our CO2. And the other thing that happens inside of a kiln is that the limestone material and a few other ingredients as well, iron and clay and things like this, get heated up in what's called a calcining reaction. And that's where we take limestone or calcium carbonate, there CaCO3 in the chemical equation at the top. And by heating it, we drive off carbon dioxide and we're left with calcium oxide, the prime constituent in cement, about 65% by weight. And so that process, the chemical process, releases about 61% of the CO2 emissions that we associate with cement production. And the fuel, the burner, accounts for only 39% of the emissions. So just wanted to set that record there so we all have an understanding of what we're talking about in this process. After we make cement, and typically for an architectural application, we mix it with water, with air, with fine and coarse aggregates to make concrete. And that's where the majority of the cement goes that gets made here in California. When we make Portland limestone cement, we take that up roughly 11% by volume that concrete is. Again, we combine it with the other ingredients that make concrete, but all of the practices and strategies that we can use to reduce CO2 in our concrete mixes, like using supplementary cementitious materials like fly ash, slag, or natural pozzolans, using high strength aggregates that may be imported in some places, using higher strength concretes to optimize our mixes and reduce the total amount of concrete needed. All of those things still work with Portland limestone cement. We're just reducing the amount of carbon associated with the actual cement by about 10%, which then of course cascades into the concrete because the cement is responsible for about 85% of the CO2 emissions associated with concrete. Here we have an example of a concrete mix design that was produced with ASTM C595 cement, which is type 1L, which is Portland limestone cement, the main topic of our discussion today. This one happens to be a Green Book mix. You can see by the designation here, this description here at the top, 565C3250P. What that stands for in this nomenclature is 565 pounds of cement, a C, they have an ABCDE system for C aggregate gradation, 3,250 PSI compressive strength at 28 days, and the P means that this is a pumpable mix. And so you can see what they've got down here is just like the description says, 565 pounds, in this case of Portland limestone cement. To get this C gradation, they use 3 different sizes of rock, a 1 inch by number 4 blend, a 3/8 inch by number 8 blend, and washed concrete sand. And of course, we have some water, we have some air. This particular mix doesn't have any supplementary cementitious materials in it, but it produces nice concrete, 3,250 PSI at 28 days, 4-inch slump. And this kind of a concrete mix is kind of the bread and butter of the concrete producers in our area. I wouldn't describe it as particularly high performance other than by its use of type 1L or Portland limestone cement being a strategy, a tool used in this case to reduce the greenhouse gases for this particular concrete. If we can be successful in transforming our market from ordinary Portland cement to a Portland limestone cement, we could be potentially saving 850,000 metric tons of carbon dioxide equivalent per year in California. And that is roughly equivalent of taking over 2 billion passenger vehicle miles driven every year off of the roads. That's the kind of order of magnitude that we're talking about by affecting this change. Ultimately, what we want to be able to describe is how to specify this material, how to build with this material, and how to quantify the savings achieved with this material. Just like was done, excuse me, it's a button too soon, just like was done on this University of California, San Diego Biological and Physical Sciences building, where they saved 133 tons of carbon dioxide just by changing the cement that they specified. Up next for learning objective number 2, Tom's going to talk about reducing CO2 emissions.
Thank you, Nate. This is really where we start getting to the heart of the matter. If you think about concrete, it is a material that we trust our lives to every day. Think about just being in the Bay Area as an example. If you're riding in the BART under the bay, if you're driving on a bridge over the bay, if you're looking at what's happening with foundations, particularly with things like liquefying soils for earthquakes, there's a lot of creative solutions happening there. Our entire water supply and treatment and flood control, all these things at some point relate to concrete. And it's like was mentioned earlier, it's used so many places. And yet, while it's so vital to our lives, there is an impact on embodied carbon that relates directly to the objectives that so many of you, I'm sure, are working for firms that are committed to Architecture 2030. And you can see that the goals for reducing embodied carbon are getting bolder and more aggressive. And this is something that has also caught the attention of the structural engineers community. We're encouraged to see that they are also aligning with these goals. This is a chart showing how both the AIA, Architecture 2030 and SE 2050 are working together to address all these areas of operational and embodied carbon. Along those lines, it's not just the built environment and the architectural community that cares about this. The state of California is in the lead, as you would expect. The state reached its goal by getting to 1990 levels of greenhouse gas emissions by 2020. And now the state by law is focusing on an aggressive goal to get to 40% below 1990 levels by 2030, and with the goal of being at carbon neutrality and net negative starting after 2045. So we realize the cement industry is an important part of this. If we look at where we fit in terms of contributing greenhouse gas emissions in the state of California, you can see up here in the upper left-hand corner that the cement industry contributes 1.8% of the state's greenhouse gas emissions. That is why we are a part of the California Air Resources Board as part of their target industries to make reductions. You may look at that and say, look at this chart and see buildings over there at 8.7%. Wonder about other materials that we compete with, such as steel or timber. Those are largely imported into the states, and even concrete. You don't see concrete on this list because, as Nate mentioned, about 85% of the CO2 impact is related specifically to cement. And that's where Portland Limestone Cement can start making a difference. The next slide will explain the commitment that our industry has recently taken, and it is cutting edge. Our industry has released a carbon neutrality plan earlier this year. You'll see in the next slide that Portland Limestone Cement accomplishes part of the 10% of this goal. But if you look at these 3 pathways and 9 levers, specifying Portland Limestone Cement is the one lever that can be pulled by you. It's something that you can specify on projects. All of these other entities, whether it's looking at carbon capture or waste heat recovery, these are things that happen at cement plants. And as shown on this graphic, as you look across the top there, in order to make these things happen, it requires things like legislative assistance, regulatory assistance, and public acceptance. There's a lot of effort involved in making these goals real. And this is, again, where you are a pivotal part of this progress. We really want to start a movement that's already begun, and we want to accelerate as much as we can to move away from the traditional Portland cement that's typically specified on all of your projects, and to inspire all of you to allow blended cements on future projects that include Portland Limestone Cement and others. This is a simple change that will show you how to make at the end of this presentation, but a lot of this depends on demand. A cement manufacturer needs to respond to demand in order to change the way it creates its product. So this is, again, where you play a pivotal part. I also wanted to mention something that we're very proud of. And I also want to tip my hat to the AIA California, because as I get your emails and look at your website, it's very apparent that the chapter is closely aligned with looking at legislative issues. And in this case, this last legislative session, our association was very involved in shaping a landmark piece of legislation to decarbonize the cement industry. It's called SB 596. It's the first bill in any California sector to focus specifically on achieving net zero emissions. And we're pleased that much of this aligns with our carbon neutrality plan. And now this is where you get to put your seatbelt on and go back to school a little bit. This is where Nate will show you the sort of information that he really gets into when he's talking to structural engineers. And I want to mention that the majority of presentations we give like this are focused on structural engineers, because we realize how pivotal they are and how you look to them to make changes like this to the projects you're working on. So Nate, it's back to you.
That's right, Tom. We want to make sure that, everybody has access to the information that they need to be able to make these decisions. When you, as a design professional, decide that there's a need and a willing owner to reduce greenhouse gases in their buildings, we want to make sure that the engineers that you're working with know about this material, are comfortable with this material, so that you don't hit roadblocks when you go to implement it. We're going to talk a little bit about how Portland limestone cement works, how it works a little bit differently than ordinary Portland cement. A few different ways here that we're not going to get into in a lot of detail, but we'll give you a little bit of a flavor here. The first is by particle packing. Now, this is very analogous to a well-graded road-based material. We don't want to build a road base out of only fine sand. We don't want to build a road base out of only coarse aggregate. We want a well-blended or well-graded mix. And Portland limestone cement, by virtue of being much smaller, the limestone particles being much smaller than the cement particles, are able to pack into those spaces in between cement particles and give us a higher density paste in the concrete, which helps to maximize the density in there and minimize the void space in the concrete. Additionally, we create more nucleation sites for the formation of the calcium silicate hydrate crystals that are the product of the pozzolanic and hydraulic action of the cement. This enables the reaction to take place. It begins at more places, and the crystals don't have to bridge as far between cement grains because these limestone particles are in between them. And then finally, we have a chemical reaction that takes place, particularly when we have slag cement, and also in some instances with a fly ash supplementary cementitious material, where we get a product called carboaluminates. And as we'll see on some slides coming up in a minute here, oftentimes the presence of these supplementary cementitious materials in beneficial harmony with the Portland limestone cement result in concrete that's even stronger. We have a series of PDFs here that explain some of how this works and what to expect. And as we're talking here, Tom is going to upload a PDF into the chat window that you can download. It was, Tom, about 4 or 5 pages of PDFs here about Portland limestone cement. But the general theme here is that this is being intentionally formulated to be a one-to-one replacement for ordinary Portland cement. You should not expect major changes in terms of workability, in terms of surface finishability, in terms of setting time, in terms of strength gain, compressive strength, freeze thaw resistance, sulfate resistance, et cetera, et cetera. We could go into great detail where I could pull out some really exciting graphs and charts and quotes from different academic studies and get into all of these properties, comparing ordinary Portland cement from Portland limestone cement. And we can do that if you'd like, but we're not going to do that today on this agenda. I'm only going to put up a few graphs where I compare Portland limestone cement to ordinary Portland cement. What we've got here is some laboratory research that was done by Dr. Michael Thomas at the University of New Brunswick up in Toronto, Canada. He compared strengths at 1, 7, 28, and 56 days. Portland cements, which are in kind of the lighter gray bars, Portland limestone cements, you'll see that 12% on the graph there. This Portland Limestone Cement happen to have 12% limestone. And the strengths with no supplementary cementitious materials, a 35% slag mix, and a 20% fly ash mix. And you can see in the case of strength at 1 day and 7 days, the Portland Limestone Cement was coming out a little bit ahead of the Portland Cement. When we look at the same mixes at 28 and 56 days, we see much the same, although it appears that the ordinary Portland Cement caught up a little bit and maybe past that fly ash, 20% fly ash at 56 days. But again, the theme is very comparable performance because this is formulated to be a 1-to-1 replacement. More recently, Caltrans undertook an extensive research project in conjunction with Oregon State University to look at how the implementation of Portland Limestone Cement in Caltrans specifications would impact a lot of the work that they do. This was a pretty large project where they imported lots of materials from California, cements, Portland limestone cements, limestone powder, supplementary cementitious materials, aggregates, etc. All these materials were imported from California sources, made by California producers, and ultimately batched into concrete, that would serve a Caltrans specific mix design for a pavement or for a structure, as an example. So this is very applicable, the information in this study, to what we're doing in California, both in public works type projects as well as buildings. Many topics here that were studied in particular in this study, 321 pages of excruciating academic detail on all of these various topics concerning the comparison of ordinary Portland cement, Portland limestone cement. We could talk about this study for hours. You could probably read it for days. It's a certain to cure your insomnia, but I'd be happy to share it with anybody interested in reading it for themselves. A particular interest, I think, for our audience today, we wanted to touch on construction schedule and the impact on greenhouse gases. We have a couple of excerpts here from that portion of the study. And this is a quote from the study. In general, the addition of limestone, whether in ground or added to the cement, had no statistically significant influence on the final setting time. So what that means is whether your concrete is ordinary Portland cement or Portland limestone cement, you would expect it to behave the same in terms of the timing of your construction. And then additionally, regarding greenhouse gases, this study found that the reduction in greenhouse gases from using Portland limestone cement could be between 6.5% and 17.1%, with an average of 10 to 12%. We're generally mentioning 10%. That's what we're seeing is probably the most likely scenario. But due to the synergies of this material with the supplementary cementitious materials, like I mentioned earlier, there's a lot of opportunity here for further reduction by going down, utilizing the tools that we have available to us in terms of mixed optimization and supplementary cementitious materials. And so to that end, Caltrans is incorporating this material in their standard specifications. That standard spec is to be published on Friday, October 15th, 2 weeks and 3 days from now, if my math is right. And at that point, it's going to be the standard material, or a standard material, excuse me, in the Caltrans revised standard specifications. We have this slide up here that talks a little bit about PLC acceptance and adoption over time. And this is to make the point that while Portland limestone cement is new to California, it's not a new material at all. It's been used in Europe for 5-6 decades now. Been used in Canada for about 14 years. Been in place in other states around the US for about 13-14 years now. And to that end, there was a study done, about 800 lane miles that got paved in 3 states. Back in 2008, the Concrete Pavement Technology Study Center from Iowa State University did a review of these pavements when they were 10 years old and found that they were performing very well. And the point of having this in here is that we want you to understand that, under very harsh service conditions, you can imagine a pavement in Colorado getting de-icing chemicals on it, getting multiple freeze-thaw cycles, getting heavy trucks, getting studded tires, getting chained up vehicles driven on it for now 13 years, and the pavement's behaving just great. Well, we also want to put some examples up here of some beautiful architecture, and Tom is going to walk us through these examples.
Thank you, Nate. Thought I'd show some examples of projects starting in Vancouver, British Columbia. You may have noticed in the previous graphic that Canada adopted Portland Limestone Cement as early as 2007. So this is an example of a market that has completely transformed to Portland Limestone Cement, as has the Seattle market. And that's, again, where we really hope to go with your help. So here's an example of a project in Vancouver, what they've been able to do through the help of the Cement Association of Canada. They've been able to give us these examples, but also quantify the savings on these given projects. And I show these to you because we just think they're an impressive array of building types and structures. If you keep flipping through these, Nate, that would be helpful. Here's an example of a hospital building where in most cases, these are concrete structural frames where they've been able to quantify both the amount of concrete used, the amount of Portland limestone cement that's been utilized as well, and the tons of greenhouse gas emissions that have been saved. So these are big projects and impressive ones. You'll see here that what's easy to do as well, when you see a figure like 2750 tons of CO2 saved, we're going to show you how in your own office or by contacting us, you can start using some of these comparative tools to show the equivalent number of cars removed from the road, or in this case, the number of acres of forest in a year that equates to that tonnage saved by just switching the type of cement used on a project like you've seen on these previous photos. And here's one too, where I thought I'd just look at this quote from Kerry Kobzinski, a very forward and progressive thinking structural engineer who is designing this project under construction right now in Seattle. It uses concrete up to 15,000 PSI in conjunction with high strength aggregates. But as you can see in his quote, his firm is committed to helping the concrete industry reach net zero carbon emissions. And a valuable tool in this effort is using Portland limestone cement, which is used on this project for everything, the foundations, the shear walls, the columns, and the slabs. And it's really the way to go moving forward. So I show these projects in order to help you feel more comfortable with the idea. As we move closer to California, the one market where we've seen the most use of Portland limestone cement has been in San Diego. One of our member companies has provided these projects to us to look at, all of which have used Portland limestone cement in the cases like you see on the upper left and upper right for the structural frame of a laboratory building and a parking structure, an office building. Lower right is a high-rise residential tower. Then also in the middle, on the bottom there, a pool deck. The project on the lower left simply used it for the architectural concrete. But in each case, you have the amount of concrete used on each of these projects. It's not hard for you, not hard for us to help you do the calculations with this sort of information that can show the real life reductions you're making in embodied carbon. And to drive this home in a really real way, I think this is an example that really speaks volumes. This is the University of California, San Diego, North Torrey Pines Living and Learning Center. This project was completed in August of last year. A massive project, a very impressive project on that campus, very worthwhile to visit if you get the chance. But if you look at this chart on the screen here, you can see that the environmental product declaration provided by the supplier of this Portland limestone cement compared it to their typical type 2.5 cement. So you can see the difference is about 10.1% in terms of that company's specific improvement on Portland limestone cement versus traditional cement. Again, you can look at the 3,055 metric tons of CO2 saved by making this change, equating to 664 cars for 1 year. So there's an example that we feel very proud of. And in this case, all of the concrete above grade is using Portland limestone cement. Beautiful architectural concrete too, I might add. And now we want to leave you with specific steps that you can take to implement this on projects that you're working on right now.
Thank you, Tom. We mentioned this earlier, but at present, our market tends to be an ASTM C150 cement market. You're probably familiar with the terminology 2.5. Our goal is to drive this to a market that specifies ASTM C595 type 1L, which is also called Portland limestone cement. I put up this little cheat sheet here so we have an understanding of the different types of cement that are available under each of these two ASTMs. I mentioned we're probably most familiar with the C150 type 2, which is for moderate sulfate resistance, and the type 5, which is for high sulfate resistance. And those have very, very close analogs in ASTM C595. Instead of being a type 2 or a type 5, we would call that a moderate sulfate resistance or a high sulfate resistance. Looks like we've got our arrows pointed in the wrong place here, but we would use the terminology MS and HS for this. But this is, and the reason that those are such close analogs is that product that comes out of the kiln is exactly the same product. It's just blended a little bit differently in its final stages of production. We mentioned earlier specification guidelines. These should be in that PDF that's in the chat if you want to download that and take a look at it, how to specify it. It's already in several spec documents that you may be using, the AIA master spec, Federal Aviation Administration specifications. We'll take a look at a little bit further in just a second. Specs intact. And as well as some documents you're probably familiar with, ACI 301 specs for structural concrete, ACI 318 building code requirements for structural concrete. These already include references to that ASTM C595 type 1L. We have an interesting example here from the Indianapolis Airport Authority. They're reconstructing a runway. Their project, the bids are closed, but I'm not sure they've awarded the project yet. It's very interesting in their specifications, they're only allowing Portland limestone cement. In fact, this is the exact language from their specification following the Federal Aviation Administration format. They are in section P501 for concrete pavements and 501 2.2 cement shall conform to the requirements of ASTM C595 type 1L. So very interesting that in this case, Indianapolis is leading the way in specifying a modern low carbon cement. We would very much like to see this sort of thing being specified in California and are working with people to this end, people like yourselves. The Portland Cement Association has launched a new website called greenercement.org. You can also get there at greenercement.com if you're like me and can't ever remember what the extension is on that. But it's got lots of information about Portland limestone cement, different case studies, different places it's been used. One of the most useful aspects of it, though, is a calculator to estimate your potential CO2 savings by specifying Portland limestone cement. I went ahead and ran this estimate using a Caltrans project. This is a concrete pavement project on Interstate 10 out near Blythe that's slated to use 465,000 cubic yards of concrete, so it's a big project. And I estimated 430 pounds of cement per cubic yard, probably be closer to 500 pounds of cementitious when you factor in the fly ash that Caltrans tends to use. And the estimate we came up with is 7,383 metric tons of CO2 savings. So we might be saying, well, what does that really mean? My next step is always to head over to the US EPA's website, Greenhouse Gas Equivalency Calculator. We can plug in that same number at the top. You see 7,383 metric tons. And it gives us a number of different equivalencies, passenger vehicles driven for a year, miles driven by an average passenger vehicle, different amounts of gasoline, diesel, coal, et cetera, et cetera. I've kind of cut this off in terms of a screenshot. There are, I think a dozen more different equivalencies down there. And I find this website very useful when we're talking to elected officials, policy makers, et cetera, because we're all relatively new in terms of speaking about the impact of a specific number of metric tons of CO2 avoided. And so this certainly helps to have some different equivalencies handy to help make your point. Also want to draw your attention to some interesting information that came out of the COP26, which is the latest report from the Intergovernmental Panel on Climate Change. They have for the first time recognized that concrete is a carbon sink. When we put concrete in place over its lifetime, 40 to 60% of the CO2 that was emitted in the production of that concrete gets reabsorbed by the concrete itself. So this is fantastic news, something that didn't get as much press attention as maybe we might like, but want to make sure that you were aware of that. They also had some interesting findings on the total impact of cement production in the world. You would probably see mentions of numbers like 6 or 7 or 8% of the CO2 emissions in the world. This report found that that number was closer to 4%. So interesting information. And finally, we wanted to just touch on some frequently asked questions here. These always come up, and I haven't been looking at the chat or the question and answer boxes here, but I suspect some things like this are probably being asked already. So we'll go ahead and mention them. As far as the color of Portland limestone cement, you should expect it to be roughly the same as ordinary Portland cement. It may be a little bit lighter, but basically undetectable in place. Now, I want to caveat that by saying one of our members that we've mentioned on here, CalPortland, does sell a light colored, they call it Advancement LT, a light colored or white product that also is a Portland limestone cement. So that particular product is much lighter, but it's lighter by virtue of being a white cement, not by virtue of being a Portland limestone cement. Additionally, in terms of cost, our members are not positioning Portland limestone cement as any kind of a cost premium. The cost is right on par with ordinary Portland cement. So this is not a premium product. It shouldn't require any, any special handling, any special proportioning. We saw that it was a 1-for-1 replacement in terms of performance in the concrete. And so you shouldn't really expect any differences there. I will again caveat that in terms of that white cement, that Advancement LT it's called, as a white architectural product, that material is a cost premium, but again, it's a premium because it's a white cement, not because it's a Portland limestone cement. That same member, CalPortland, also produces a Portland limestone cement they call Advancement HS. You may recall that HS stands for high sulfate resistance, and that is the product that's right on par cost-wise with their ordinary Portland cement. And then finally, availability. I've mentioned CalPortland a few times. They make Portland limestone cement as a regular part of their production at their Mojave facility out off of State Route 14 north of Palmdale. They have it available all day, every day. You can drive a truck out there and load it up with Portland limestone cement and do whatever you'd like with it. Additionally, another member of ours, National Cement, is producing Portland limestone cement regularly. And our other members, are in various stages of getting their blends, moved along, getting their approvals, getting their mill certs in place. And with that October 15th acceptance by Caltrans, we're anticipating the landscape to change pretty quickly in terms of availability on this material. And so with that, we'll put up our contact information here, which I think will also be available from AIA when you get the recording of this presentation and the PDF of the presentation and so forth. And then I'll stop sharing my screen here and we can take a look at some of the questions and open it up to other questions that anybody may have.
Okay, boss. Nina put in a question very early on, so it kind of takes off on your color issue here. Have you discussed testing PLC in combination with the new whitest paint in the world developed by Purdue University and it appeared in the recent stories in U.S. News and World Report? The question here is to reduce heat and carbon emissions. So I think you touched on carbon emissions a little bit, but by using it, we also get, the urban heat island effect gets diminished as well.
Yeah, I think there's some fantastic applications for that whether it's specifically paint or some other super white material that may be able to be engineered by virtue of this material discovery on building roofs, possibly even building walls. I don't know as far as specific testing on that paint on concrete. I'm not aware of that. We do at times discuss using concrete pavement as a means to reduce urban heat island effect, by reducing pavement temperatures and things like that. It's pretty readily demonstrable that concrete has a much, a lower temperature, a higher albedo, if you would, for that material, but not specifically with that paint.
Okay. Megan's question is, are there any downsides to specifying Portland limestone concrete? What are the potential arguments that we might hear against using it versus Portland concrete? We probably get this question a lot, if you're using something new.
Yeah, I would guess that would be the chief argument is somebody's kind of lack of familiarity with it. We show that information about the various stages of adoption around the world and around the country. We like to think we're leading the way here in California, but that's not really the truth with this particular material. At this point, there are 34 or 35 other state departments of transportation that have already approved Portland limestone cement. Caltrans just a very cautious from an engineering perspective and wanted to perform their own research to create a basis for acceptance. And they've done that now and will be on board as well. So I would anticipate that kind of lack of familiarity being the biggest thing. And I would say that, if you run into that, we're happy to help. Tom talked about upfront how we're a resource. If you have an engineer, for example, or a contractor that's not sure about it, maybe wants more information, we're happy to go talk with them.
I know from experience, if it's a Caltrans mix, it's Caltrans specified, you're in pretty safe territory.
Pretty a lot of conservatism built into what they do.
Yeah, so from what you've shown today, in terms of performance, it seems it's pretty much straight across the board. So structurally, it's the same. John's question, any change in the air void system, size and spacing?
No. And typically here, where we are in Southern California, we don't intentionally entrain air in the concrete, but when air entraining admixture is used to help combat freeze thaw, the Portland limestone cement behaves just exactly the same as ordinary Portland cement.
Okay, Elizabeth's question, the concrete is a carbon sink. Is that just for PLC or does that work for any concrete?
No, that's all concrete. That's the term that explains that phenomenon is called carbonation. It's a natural phenomenon that occurs in all concrete.
Okay, Robert's question, what are the aesthetic effects of Portland PLC, color, texture, etc., as compared to standard cement? I'm assuming that's the finished surface.
Yeah, that you might expect it to be slightly lighter, but possibly not. It's going to really depend a lot on the sources of limestone and other ingredients that are available to a specific cement plant at a specific time. If you're particularly concerned about the color of something, I really recommend you do a sample panel, a referee panel, something like that, if you would, and
a test panel. Yeah.
So I wanted to mention too, relating to color, oftentimes it's your supplementary cementitious materials that can make a larger difference than switching cement types. So slag will typically make your concrete lighter, and fly ash will typically make it darker.
Yeah, and then as far as the finish on it, if anything, we're seeing a little bit a reduction in bleed water, which can make the surface a little stronger, which can make the surface a little easier to finish. Not long ago, I stopped by some projects in the Bakersfield area for a ready mix producer there who switched over completely to Portland limestone cement. And we talked to the laborers that were finishing a house slab when we were there. And I don't think they were aware that the concrete was Portland limestone cement. It was finishing out just fine, just the same for them.
Okay. Megan's got a question here. Does changing from Portland concrete to Portland limestone concrete change how much carbon the concrete absorbs over time?
No, I don't think so.
Okay,
shouldn't be a change in that. There's enough. We're only talking about a change. I guess we didn't get into specific detail about the actual manufacturing process, the difference between Portland cement and Portland limestone cement. But in the Portland cements that we're used to today, your C150, type 2.5s, or even type 3s for that matter, if you need a higher early strength, those are allowed to be up to 5% limestone, and Portland limestone cement is allowed to be up to 15% limestone. And so the calcium oxide fraction of the concrete, in terms of when we mix the concrete, it goes from 95% to 85%. So we still have lots of calcium oxide to react with the environmental carbon dioxide in that carbonation aspect that we mentioned.
so it has, I mean, common sense would say if you have less concrete, you'd have less absorption.
Well, the carbonation happens on the surface. So it has a lot to do with the dimension of your member, not so much the total amount of concrete used in the member.
Okay. Okay, Robert's question, I like this. Does Portland limestone concrete react differently with slag, meaning any effect on the greening strain of the concrete?
It's sometimes a little bit higher strength owing to that carboaluminate formation in the concrete matrix. Outside of that, no, it's about the same. And Frank, maybe I'm not sure I understood the final aspect of that question.
Staining of the concrete.
Staining, no, I haven't seen anything about staining with this.
Okay. Paul's question, does changing from Portland concrete to Portland limestone concrete affect any dosage rates of admixtures as far as air entraining admixture or water reducers?
No, I wouldn't expect a change in the dosages of that, but if anytime you're going to be developing a new mix design, I would really encourage, some testing, some trial batches to prove out the performance of what you're trying to do. The ready mix producers, if they have established, mixes, and they're going to be switching cements from ordinary Portland, the C150, to Portland limestone, C595, they would want to be doing some testing anyway. Like I said, it really is being formulated to be a one-to-one replacement. I personally wouldn't take that so far as to mean no testing is required.
Okay. I like this one. Are there any issues about using Portland limestone concrete on tilt-up wall construction?
No.
Okay, that was easy. This is a good one. Are EPDs available for Portland limestone concrete?
The EP, so let's get a little bit clarity on this. There are EPDs available for the cement, the Portland limestone cement, and depending on who your concrete producer is, they may also be able to generate environmental product declarations for your concrete. Now, those are two different things. Of course, the EPD for the cement feeds into the EPD for the concrete, but in a building setting, you would probably be most interested in the EPD for the concrete. So it's going to depend on who your concrete supplier is and kind of where their technology lies is insofar as their ability to do that.
Okay, for a little clarity, you're talking about the concrete or the mix itself? Because on the mix design, I don't know if you'd have an EPD, would you?
No, a mix design is not an EPD.
Right.
Those are separate documents. Right. Every concrete mix that's going to be produced at a ready mix plant, for example, requires a mix design because the weighmaster has to know how much of every constituent to put in that drum, to put in that truck, etc. Now, not every mix design has an environmental product declaration. Those are becoming more common, and there are some ready mix producers now that can produce a product specific environmental product declaration. But my latest understanding from a representative from National Ready Mix Concrete Association is that nationwide, it's about 3% of plants that can produce those at the moment. Now, some of those we're probably ahead of that curve in California. It's probably a higher percentage than that. I don't know. I don't know if I could answer much more specifically than that.
No, I think that's good. It's
Frank, I just wanted to offer one thing here too. You've been mentioning Portland limestone concrete. It's really Portland limestone cement. I just want to
Yeah.
make sure everybody recognizes cement's the binder that holds concrete together. So we're really looking at that cement binder, which is the main CO2 component of concrete. And we do have another face on the screen. I just want to mention Tim Blake is here. He is another contact for any of you working on projects where you may be considering this. He's also very good at making connections. And one of the things he always inspires folks in architecture firms to do is not only to look at the greenhouse gas saving potentials for a project, but across your entire firm. So if you look at what you do in a given year, all of a sudden you might be able to make some pretty impressive claims with what this small little change seems like on the surface can really start adding up. Just want to throw that out.
Hey, Tom, this is Lionel. I just want to address the issue of EPDs and concrete. Pretty much any ready mix concrete producer, NRMCA member, and some non-NRMCA members, if there's a requirement in the specification to publish an EPD for the purposes of measuring environmental impacts, especially for lead projects and that kind of thing, they will do it. Now, likely they won't do it voluntarily for every project, only because they're pretty expensive. And concrete plants have literally thousands of mix designs, and it would literally cost tens, if not hundreds of thousands of dollars to get EPDs, publish them proactively for all those mixes. So the point being is that if you have a goal of reducing embodied carbon footprint, and you specify environmental product declarations as part of the submittal process, I don't think there's any company out there that can't do it. It's easily done.
That's good to know, Lionel. Thank you. I think you touched on this real quick. Is there any difference in cost between Portland cement and Portland limestone cement? Right.
No, there's not intended to be. Cement's a very competitive material, so everybody's trying to, do the best they can to stay competitive cost-wise. And what we understand from our members, we have some direct quotes that we didn't put in this presentation, but essentially they're selling Portland limestone cement at the same cost as Portland cement.
Architects like a lot of reassurance on cost.
The only exception to that is if you're looking for that lighter color version, which would typically be more expensive anyway.
Right.
But it looks great in architectural concrete.
Okay, David's question: how critical is the use of fly ash with PLC to get the maximum product performance? Is the fly ash replacement comparable to the replacement associated with regular Portland cement?
Well, yeah, that's an interesting question. Let me start at the end. The fly ash replacement, in terms of increasing your performance or maybe improving your durability, that replacement level is the same. Now, in terms of a need to use fly ash for maximum performance, that's a bit of a misnomer. Fly ash can improve performance in some ways, but so can lots of other supplementary cementitious materials like slag, like metakaolin, like natural pozzolans, like silica fume. There's a lot of stuff, a lot of materials available in our marketplace, and depending on what we're thinking of in terms of performance, right, that could mean a lot of things. That fly ash may or may not be the right supplementary cementitious material for your application.
Okay, I'm going to take two more questions and then we'll have a wrap here. But has Green Book included PLC in their specifications?
Not yet, although I know the chair of the concrete ad hoc committee at the Green Book, and I know that they're working really hard on it. I know that because I am the chair of that committee, and I feel pretty confident that it's going to be in the next revision, whether we get into a spec update, a mid-year update, or the next actual printed book, but it'll be in there soon.
For the UCD project, you said that it was above grade. Could PLC concrete be used below grade?
It certainly can. Yeah, here in California, we have soil sulfate concerns and soluble sulfate concerns in groundwater as well. And there is moderate sulfate resistant and highly sulfate resistant versions of Portland limestone cement. That was a an early and frankly now outdated concern that Portland Limestone Cement concretes made with PLCs might be more susceptible to sulfate attacks. And the research at Oregon State and in other places now has indicated that that's not the case. So to answer the question, yes, PLC can be used
Major
below grade
reason.
as well as above grade.
That's a major reason for the research that Caltrans did, just to confirm that.
Any change in the dosage rates for AEAs or water reducers?
No, should be the same.
Okay,
Although-
that's
Although I would, you know, if you're looking for something really specific in terms of performance, again, I would encourage some trial batching.
last question and we wrap. Okay, does PLC have a different pH than conventional cement?
No.
Okay, that's good. Okay, a big thank you to Tom, Nathan, and Tim for an excellent presentation. If you've made it this far, AIA California staff will submit your AIA CE credit, and it'll appear on your transcript in a couple of weeks. There's more resources on the AIA California website. There'll be more added from today's presentation. There's more details on the upcoming AIA Climate Action Series that'll be shared with you via email. I want to thank everybody for coming and joining today. It was a great set of questions. I'm very pleased with the questions. Very, very, very pleased with the presentation. I love the depth. I loved it was all good, boys.
Well, thank you
Fantastic.
very much for being such a great audience, and thank you for your participation and the interaction there at the end. It's always great to get questions from the audience.
It's nice to be able to talk to guys just like we do in the office here. So, you know, it was great.
do our
guys.
best.
Really appreciate it very much and thank everybody. So that's it. Have a good,
Right.
go to
Thank you,
lunch.
everyone.
Good afternoon, everybody.
Thank you, everyone.